Good morning, everyone. My name is Marc Godin. I work with PTAC, the Petroleum Technology Alliance Canada, and I'm here as well as part of CRIN. I am the lead of the methane theme area of CRIN, where we have supported the development of several new technologies and knowledge sharing around reducing greenhouse gas and methane emissions. I'll do a very quick introduction and then move on quickly to our speakers, which is the main topic today. I'll first start with a land acknowledgement. Acknowledgement of the land is an important step toward reconciliation. Today, we are gathering from across Canada and, in fact, North America. Please take a moment to recognize the land you reside and work on. This event is being hosted from Calgary, where we acknowledge and pay tribute to the traditional and unceded territories of the people of Treaty 7, which include the Blackfoot Confederacy, which is comprised of the Siksika, the Piikani, and the Kainai First Nations, the Tsuut'ina First Nation, and the Stoney Nakoda. The city of Calgary is also home to the Métis Nation of Alberta, Districts 5 and 6. We have 5 speakers today. 3 are in person. We will first start with the 3 that are in person. They each have 5 minutes to present their information. We will do question and answer at the end of all 5 speakers. First is topic is solar activated water treatment to accelerate oil sands process affected water returns. And it's presented by H2 Nano. And our speaker is Zach, who is a co-founder and COO of H2 Nano, creating sustainable solutions to energy and mining water management. Help me welcome Zach to the podium.
Hey, good morning, everyone. Thanks so much, Mark, for the introduction. H2 Nano is proud to be a part of the CRIN network, and I'll share a little bit today about a project that we've been working on since 2022 with a focus on accelerated treatment of mine water in Canada's oil sands and working with our partners there. H2 Nano is a environmental technology company focused on passive, low-energy options for water treatment with a goal of reducing both the cost, operational input, and carbon intensity of water management in energy and mining operations. The specific focus of this program is on oil sands mine water and finding a passive treatment solution to the over 500 million cubic meters of water stored in tailings operations today, with continued operations expecting that number will continue to increase over time. Though this water has not been regulated for release to the environment, and there's still intensive study undergoing on that, we're developing our technology in combination with those studies and contributing to it as a matter of demonstrating that there are alternate approaches to conventional water treatment technologies, as well as natural attenuation to accelerate the treatment and readiness for return, while doing so in a way that is both economical and more sustainable than conventional treatment technologies. Solar Pass, our light-activated catalyst technology that we're demonstrating in this program, operates between the mine water storage, doing treatment on this water to treat both the aquatic toxicity in the water and through that some of the contaminants of potential concern, in a process that is continuously reusable, doesn't require inputs of chemicals and electricity, and doesn't generate any waste or concentrate byproducts. And then downstream of H2 Nano's technology, which I'll talk a little bit about from the CRIN project today, analyzing how we can integrate with other natural remediation systems such as wetlands to achieve all of the treatment objectives that exist for returning this water. The way that we achieve this is through a sunlight-activated catalyst. H2 Nano's technology is a composite that floats at the surface of the water. So these small beads, you can think of them like little chemical factories, except instead of converting sunlight energy into electricity, we're generating chemicals from the water itself. And so these chemicals go and break down the complex organic molecules that are in the water from the bitumen extraction process. And in so doing, it converts them to being more hydrophilic, which is a matter of saying that they don't interact the same way with aquatic species, and that breakdown eventually mineralizes them so that they are no longer present as potential contaminants in the water. And so through these programs, we've demonstrated that we can both accelerate through a couple days of exposure to our technology, the acute toxicity on standard bioassays, as well as reducing the organic concentrations in the water with further treatment extent. And so through this process, we're able to both decrease that toxicity that goes away more quickly. And then with further extended treatment, we can remove a number of contaminants in the water, including organics and some dissolved metals. So you can see a picture there of the demonstration that we had ongoing in Edmonton. Water was brought down from the oil sands mining partner sites, deployed into some outdoor treatment systems. And the CRIN program supported us demonstrating that on a couple different water sources under natural conditions at the largest scale of demonstration we've done with H2 Nano's technology. And so this has allowed us to optimize the solar dose needed to reach the treatment target we want, as well as doing some of the pre-deployment de-risking in preparation for larger scale tests at the mine site. In addition to that, we also did a first demonstration of demonstrating our technology, Solar Pass, with wetland systems. So these are another technology that's being considered for treatment and remediation of some of the contaminants in this mine water. And so we wanted to study whether or not they were better together. And so through this program and with CRIN's support, we set up both an indoor test to validate and analyze this process, and then demonstrated that outdoors again in a parallel test that we were doing where we studied our treatment upstream of wetlands and with wetlands alone to see the results. Through that program, we've been able to demonstrate that we both improved overall wetland health in this short-term study, but initial indications were good, as well as showing that Solar Pass can uniquely take care of some of those contaminants upstream of the wetlands, and then the wetland be able to take care of some of the remaining dissolved metals and solids. So in combination of H2 Nano and CRIN, we've learned some really valuable lessons. We've been able to accelerate OSPW remediation, as well as not fully requiring organics mineralization to reach some of the detoxification targets we had. That we can treat a wide range of trace elements in the OSPW, as well as a pre-treatment for wetlands, promoting wetland health and being ready for larger scale demonstration. And the benefit of this partnership with the oil sands and CRIN has enabled us to get on to the next stage of demonstration, which will be upcoming, also in combination with Emissions Reduction Alberta for some larger scale demonstration at our partner mine sites. So H2 Nano continues to grow. We're focused on continuing to expand upon these successes for making water management more sustainable in the energy sector and mining. And so we're looking for additional mining, energy, and utility scale pilot partners, actually one of which that we had a project with this year that was in the CRIN network, so a benefit to these cafe meetings, as well as engagement with local stakeholders, regulators, and other public partners that can take some of the knowledge we've generated from this program as we continue to publish and share these results to contribute back to planning for what to do towards mine closure. And so within these technologies, Solar Pass, this advanced oxidation solution, as well as other alternatives for passive treatment of brines, enhanced evaporation for highly contaminated water disposal, as well as reduction of emissions from water with another technology we're working on for treating methane and VOCs emissions from water as well. So thanks very much. And thanks to CRIN for all your support for these programs.
Thank you, Zach. Our next presentation is titled, as you see, Testing Nanoparticle-Based Foam Technology to Improve the Efficiency of CO2, Enhanced Oil Recovery, and CO2 Storage. And it will be presented by Ali Telmadari. And he's with CRIN, who is an energy startup enabling more efficient hydrocarbon production and maximizing CO2 storage. Welcome, Ali.
Thanks for the introduction, Mark, and good morning, everyone. Again, I'm Ali Telmadari, co-founder, CEO at CRIN. At CRIN, our goal is to help the oil and gas company to improve their hydrocarbon extraction efficiency, at the same time store more CO2 underground and reduce their carbon intensity. And the way we do that is with our innovative nanoparticle-based foam technology that remain stable at underground condition, especially at high temperatures, high salinity and in contact with crude oil. As you can see in this quick video, that how our foam remains stable in contact with crude oil at the bottom compared to the conventional surfactant foam. So we can deploy it underground, remain stable. But how does that help us to, improve the efficiency of hydrocarbon extraction, basically? So this schematic shows how armor foam works, basically. On the left is the status quo. So whatever fluid you're injecting underground, including CO2, water, is it either for hydrocarbon extraction or for CO2 storage, or you're injecting hydrogen for hydrogen storage or water for geothermal, doesn't matter. Whatever fluid you're injecting underground, it will try to find a path of least resistance, including fractures, high permeability channels, and go through those paths and leave rest of the reservoir or pore space untouched. So what we do with armor foam in the middle schematic, we inject it underground. Because that foam is stable, as you saw in the previous video, it blocks those channels and fractures. And when operator resume their fluid injection, in this case is CO2, it will divert the CO2 toward the new part of the reservoir, access more pore space for CO2 storage, oil recovery, and energy extraction in general. So in the next few slides, I want to walk you through how we developed armor foam from the lab and bring it to the field scale. With CRIN support, we have done few pilots so far, and I will share the result of those pilots in general at the end too. So the first stage for us is formulation design. So armor foam is not a product, it's a know-how to design a stable and a strong foam. So what we do, we get rock sample, fluid samples, and everything from the customer to tailor the product for that specific pressure, temperature, and rock composition, and design the formulation that remains stable in those conditions. Then after that, it will be pilot design and manufacturing. On the design space, we look at all the data that customer have, come up with the volume that we need to block on those fracture and channels, and also how to inject this product. The injection schedule is also important, how to alternate between CO2, chemicals, and water to make sure that we get a stable product downhole. And after that, of course, we manufacture in Calgary and then ship the product to the field for deployment and injection underground. So the next step after that, of course, is field deployment. So once we ship the product to the field, there's also another important step here, that how to inject this. So we provide the injection schedule to the customer, how to inject a chemical, with what frequency, what rate, and all the details, we provide that. And then after that, we get the data, analyze the data, and provide the feedback to the customer, how much CO2 saving they have, how much incremental oil they have, and what's the benefit of armor foam in general, basically. So we have few pilots so far. So I will share with you. This is a summary of the 3 pilots that we have done so far. The oldest one is a little bit more than 1 year old. So this data is updated till September this year. And all of these pilots is supported by this CRIN project, basically. And as you can see, all of this is CO2 injection for enhanced oil recovery and CO2 storage. The benefit that we are looking here is CO2 saving and, of course, incremental oil that they can get from that, improving the efficiency and blocking the fracture. CO2 saving here means that they are injecting less CO2, but they're producing more or similar amount of oil, basically. And any incremental oil that they produce, they replace it by CO2 underground. So it means that is equivalent of additional CO2 storage. So we are still early to calculate that CO2 storage, but that's part of the process too. I mean, if you look at this table, you can see, for the first pilot, for example, they have achieved more than 17,000 tons of CO2 saving and more than, 3,500 barrels of incremental oil. And even in the last pilot, which is only 2 months old, they achieved 2,500 barrels of incremental oil and tripled their oil rate, basically, only during the water cycle. So that's one of the indication that our technology can work in water flood application as well. And that's what we are exploring currently, basically. So the last slide, which is our next step and collaboration opportunity. So what we are doing now, we are continuing the current pilot. So these are earlier stage of this pilot. Is still ongoing. This result that I showed is still ongoing, is not completed yet. And also we have multiple other pilots in progress, and we are talking to US customer to expand these pilots in US as well, and also new application, as I mentioned, for water flood. And same as previous presentation, we are looking for strategic partners to pilot our technology in different applications, including CO2 enhancer recovery, thermal application, water flood, and basically any fluid injection underground. We can help to improve the efficiency of that. Thanks for your time, and I will be happy to answer your question later today. Thank you.
Thank you, Ali. Our third presentation is titled Manville Enhanced Hydrogen Recovery Project, presented by CVictus. And our presenter is Katrina Stewart, who is CVictus Director of Biotechnology and Carbon Reduction. So help me welcome Katrina to the podium.
Great, thanks. Nice to be here, everyone. Thanks for joining us. I'll just move ahead. I'm here with CVictus to tell you a bit about our enhanced hydrogen recovery project being built here in Alberta. It's the first of its kind commercial facility using our novel patented technology. I'll run through a bit about our project and how the technology works, as well as some of our successes and challenges and next steps. So our project is to develop a clean hydrogen facility to produce low-cost, low-carbon hydrogen for the emerging hydrogen economy. But one of the largest kind of challenges we face is that we're in a chicken and egg situation where the supply and demand are kind of being developed at the same time. And from a business perspective, this presents a lot of risks to manage, as well as uncertainty in what the market and the end product actually looks like. So by our strategy to address this was developing a 7-ton per day clean hydrogen facility. And that volume is really a sweet spot for being commercially viable, but also not stressing the markets and the end user demands that are kind of still trying to be figured out. Our technology, enhanced hydrogen recovery, is a novel combination of two commercially successful technologies. So underground coal gasification was previously commercialized in the Soviet Union, and then CCS. So we've created a new way to use a conventionally very dirty resource in a clean manner, helping to reduce GHG emissions, freshwater use, and land use, all compared to incumbent gray hydrogen production techniques. And this has rapid potential for expansion, both here in Alberta and around the world. Really quickly, how this works. So we gasify the coal in situ, and we produce a synthesis gas underground, which we produce to surface through horizontal well pairs. By injecting oxygen, we can balance the chemical reactions underground to prioritize pyrolysis over combustion to minimize the amount of CO2 that we produce and maximize hydrogen content in that gas. At the surface, we separate all CO2 and re-inject that back underground into the coal seam where it came from. And this both is for permanent sequestration of our CO2, but also helps to mobilize methane and water from the coal seam towards the reaction to increase the hydrogen content of our gas even further. And a big part of the reason that this works is that the majority of our hydrogen is actually coming from that saline water formation rather than just the coal resource itself. And so we were here last year at the CRIN Cafe, and so we shared a lot of updates and progress at that stage. I'm really focused here on some of more recent learnings and successes. Throughout the project, we've been obviously refining our surface engineering and design, and we've also been working really closely with the University of Calgary to better understand our CO2 injection capacity and our modeling of that sequestration potential. So throughout these activities and our most recent calculations show that our carbon intensity is even lower than we initially anticipated. And so this is really exciting to move through the process and get more final numbers, and it actually result in better results rather than worse. So we're still This doesn't come at a trade-off with economics. We're still anticipating to be very cost competitive with traditional gray hydrogen. Also exciting, we just received a new patent back in September. So this expands our CCS technology and really sets us up for future technology development to move our products from low carbon to net zero. Back to that chicken and egg scenario thing, this has been our largest challenge for a commercial facility to be developed. There's a large unknown, and therefore it's really hard to design our product to match a market that's still finding its footing. So all hydrogen is not the same when it comes to market hydrogen. There's different mechanisms of dispensing, of transportation. You need different qualities and pressures. So trying to figure out what our product at the end of our plant gate looks like is really kind of dependent on the unknowns in the market at the moment. And another thing that's really surprised us is the delay in regulations and guidance coming out of the federal government. It's been challenging to finalize our project design with all the details required to be certified as a certain type of project. And as you can see here, we're talking years in delay, not months. So it's a bit of a challenge there when this market and this economy is really still in that transitional phase. And the next steps are really exciting for us. We're moving earth right now. We're preparing lease sites ready for drilling of our commercial wells. We are working with our contractors and vendors to finalize our drilling programs, and we can move forward on the development of our first surface facility and underground process in parallel, as our surface construction is all modular. And we'll be starting up the reactor while the surface modules are installed. Yeah, so we're really excited about the next few months and what this technology can bring to Alberta and to the world. Thanks again to CRIN for all your support on this. Yeah, we're very excited. Happy to answer questions at the end here.
Thank you, Katrina. So now we're going to switch to two presentations who are online. And the first of them is titled Stationary Seismic Monitoring, and we presented by Highfold Technology, and the presenter is Trent Hunter, who is a Calgary-based professional engineer with a passion for high voltage pulsed power. So Trent, I'm assuming that you can join us online. I will carry on here. Trent holds a BSc in engineering from the University of Saskatchewan and an MBA from Erasmus University in Rotterdam in the Netherlands. He is active in public and private companies.
Thank you. Can you hear me?
Yes, I can hear you, and we can hear you in the audience here. And I think we're trying to get your slides up, so just bear with us for hopefully a few seconds.
Thanks for the introduction, and I can give you a bit of the background on the project. Highfold Technology was created to evaluate the potential for using plasma physics to generate, sorry, I'm just trying to read as we go here, to generate acoustic waves to be used for seismic purposes. And the value is that the production of plasma seismic does not generate any GHGs. So it's a potentially very low carbon footprint project. So while the slides are coming up, I can give you some more current progress on the project. We've done a lot of work on mobilizing the technology and demonstrating it in the field. We've done 8 customer-focused surveys, and we have one permanently installed project in southern Alberta. The project is now considered TRL 9 and or commercial, and we've successfully demonstrated the technology can be safely mobilized to the field. It has a high reliability, mostly due to the fact there are no moving mechanical parts. One of the largest successes is that we've been able to demonstrate we have a tunable frequency capability, which is pretty important given the difference in projects and their specific requirements. We've also been able to manage a transition from stationary seismic monitoring, where the project started, to mobile surveys, and we've expanded our market. And we've been able to optimize signal to noise during acquisitions. Most of our current challenges and our asks of the network are around supply chain and sourcing some of our components, strategic partnerships to continue to expand our survey work. And we're currently in the IP phase of our project. And the next phase going forward will be converting our permanent facility to a solar node next year. That project is going to be worth $250,000 in capital. And we'll also be creating a mobile chassis for our field carrier that'll be remote controlled and silent to improve our signal to noise. That again is going to be a $250,000 project and should kick off next year.
Awesome. And I know we're still working hard on solving the technical issues. And Trent maybe could speak to, so you mentioned the technology reduces or eliminates CO2 emissions from seismic acquisitions and is more reliable because there's no moving parts.
That's correct.
Do you foresee or have benefits in the seismic interpretation or the quality of the data?
No, that's one of the benefits, is that we integrate seamlessly into the existing workflows. And the benefit that we could deliver, although we haven't demonstrated it yet, is the ability to generate higher frequency broadband. We're in the lab, we're able to get up to about 800 hertz, which high frequency is very important for imaging very thin beds.
So I see your slides up here. So I think, I don't know what, if you see something, and I don't know if that's the first slide. It's with brief project overview. And you're on screen now as well. Your video is on screen. So I'll turn it over to you for your presentation. Thank you, Trent, for your patience.
You're very welcome. Thank you for diligently figuring that out. So as we discussed, the project is for low GHG seismic surveys. And, oh, I skipped pages. There we go. And we're now TRL 9 and commercial in our existing work. The successes and lessons learned to date, as I indicated, safe and cost-effective field mobilization, very high reliability because we have no moving parts. We have the ability to tune our frequency to meet our customer needs in our site-specific requirements. And we've been able to transition from a stationary source to a mobile survey, which is what the bottom picture there is, and expand our market in doing so. And the other big success is, and lesson learned, is that we need to continually optimize our signal to noise in our acquisition. And we're doing that with our partnership with the University of Alberta. Our current challenges and asks of the network, we're always looking to reduce our costs and improve our supply chain. There are some things that we continue to focus on to improve on the supply chain side. We continue to look for additional strategic partnerships to expand our survey work. And we're currently in the middle of our IP deployment and our IP strategy. The next phase of our project is to cut the cord, so to speak, with our existing permanent node and take it solar. And that should happen next year. And we're also looking to deploy, I guess is the right word, a remote control, all electric mobile chassis for survey work. And that'll also happen next year. So our source is 100% electronic. We use an electrofluidic proprietary technology. We have 0 moving mechanical parts and a small footprint. The 2 pictures you can see there on the right. We generate a high signal broadband frequency spectra. We're a very low energy, 0 to low GHG solution. We've demonstrated the technology environmentally from +45 to -45. And on the power side, we can run it off the grid, we can run it on a generator, or we can run on solar panels. As I indicated, we have very good shot-to-shot repeatability. We integrate our event timing with GPS, and we can integrate with all recording sensor systems. Ultimately, we are facilitating the economic acquisition of very high density seismic data. It's universally adaptable for various applications. As I said, we started with stationary quasi-permanent monitoring. We've now moved to mobile surveys. And it's an ideal system for measurement, monitoring, and validation, which is for asset management, whether it's CCUS, SAGD, or general compliance. This is a few picture collage of the survey work we've done around Canada and the US. The fiberglass hut is the enclosure for our permanent monitoring system. And then what we do is we deploy our tool on the front of a standard commercially available rental skid steer. And we use that to deploy it currently. And as I said, next year, we'd like to go away from this model to a all electric remote control device. And lastly, just a slide and a few panels on the actual data we generate. The top is the permanent monitoring examples. We have done some test work in Texas where there is receivers 2 miles down or 10,000 feet, which they can see our signal quite easily. And in Alberta, it's much shallower. It's only 300 meters, but again, quite good signal. And on the bottom panel is a mobile survey we did where a existing survey was being conducted, but they couldn't get down some very narrow, muddy roads, and we're a smaller, lighter version. And we were able to collect the data to get continuous coverage for the client in their project. And as I said, we have a very broad spectral content in our signal. So generally, it's being well received. So thank you very much. Any questions we can talk about later?
Thank you, Trent, and thank you, Lindy. So next, move to our last speaker online as well. And the project title is Waste to Fuel, Accelerating Commercialization of the Lowest Cost and Smallest Scale Novel Biogas to Renewable Natural Gas Upgrading System. And it's presented by Hydron Energy. And the presenter is Sohail Kiavi. He is an inventor and an entrepreneur specializing in clean energy with numerous patents in gas processing. help me welcome Sohail to the presentation. Thank you, Sohail.
Thank you. Thank you very much for the introduction. I appreciate it. So I'll share my slide screen here. Hopefully will go smoothly. Everybody has my image and also the slides. Please
Yes, we can see your slide and your video. Everything is working perfectly.
Thank you very much. First of all, I want to thank CRIN for arranging and organizing these events. Very, very helpful, useful. And I learned a lot since morning listening to the rest of the presenters. So Hydron is company that we started back in the end of 2020, going after pre-combustion carbon capture. In other words, clean fuel or fuels that they have net zero carbon footprints. And the goal for this project was to do a demonstration. What I learned from my prior startups, always the when you claim something that is extraordinary, you need to have really good evidence, and the best evidence is actually testing it and let the customer, in fact, observe the test. So, in other words, field testing. So this project was focused on field testing and scale up. So a little bit of a background here: the net zero challenge, as you know, about 30% of the carbon that needs to be captured. Actually, it is hard to decarbonize. That sector is like heavy industry sector, heavy duty transportation. You cannot use electricity batteries for those. It doesn't work. And you need to do something different. Otherwise, we are stuck with this 30% of the carbon footprint that's going to remain. And why this is happening is simply because the current processes to generate clean fuels or biofuels, biogas, syngas from pyrolysis, they generate what we call the raw fuel. It needs to be processed. The whole refinery industry and oil and gas industry only got to their peak production after they had their refining process properly industrialized. And the current refining systems used in industry, even for the biofuels, are still same old technologies that were developed for oil and gas, like membranes, pressure swing adsorptions, amine, solvent wash. These are all technologies being used for oil and gas industry. And the problem with them that they are expensive and also high carbon footprint they have. When they were developed about 50 years, 30 years, 80 years ago, nobody really back then cared about carbon footprint. So the technologies are very carbon intensive. So we need to take care of that problem. And that problem is coming up with a new platform or a product. Technology could be used for cleaning different fuels without having a negative impact on carbon footprint. And what would be better teacher than just nature? So we look at how the nature does this. So in my slide here at the bottom, you see human lungs. So we got each of the lobes of the lung. In lungs, you have these very tiny passages that turns the gas to high surface area laminar flow. Then you have those sacs that they are the membrane between the blood vessels and the gas. So they have high surface area, and also there are active groups that passes through the sacs down inside of the blood vessels, and inside there in the blood, and you have things that removes or regenerates carbon dioxide. So in our case, we have carbonic anhydrase, which is an enzyme in our body that grabs carbon dioxide from inside of our cells and it brings it to lung and releases. And then when you breathe out, all that carbon dioxide comes out. So this is the way that our body takes care of carbon. And as you know, we don't carry a big backpack of a compressor or a vacuum pump for our young lungs to operate. I mean, except people that they need the extra oxygen, but our lungs works in ambient condition. It doesn't require high pressure, doesn't require high temperature. And that was the clue. And we said, let's figure out how that's done and try to do it in an industrial way. So the parallel pictures you see here is exactly what we developed. For the way that the gas flows are handled, we developed the rotary valve for our the laminar flow passages. We have this very fine parallel passage contactors. And for the high surface area, we have this material that we have, which is a hybrid metal-organic framework that we developed. And in the body of that hybrid metal-organic framework, carbonic anhydrase is playing the role for removal carbon dioxide. So then you say, why you did all these? Well, simple, because we wanted to get something that would separate and clean up the fuel under ambient condition. And when ambient condition, whenever you use a process under ambient condition, it means that your carbon footprint is low. First of all, you're not using a lot of energy. Second of all, you're not using heavy industry to generate thick steel vessels, high pressure Azmico, this and that. You don't need any of those. So you can make it very cheap, low cost, which is low carbon footprint. And also you're not going to use heavy unit operations like compressors, vacuum pumps, and boilers. So that reduces the cost of it and also reduces the carbon footprint. So at the end, what happens is that you have half a cost, that was our target, go down as low as half a cost of other technologies and reduce the carbon footprint by about 75%. So we were successful achieving these goals. Of course, I want to just add one more thing here is that it's a platform technology. It means that it has other applications. So we do currently biogas upgrading. That's a low-hanging fruit. And then next thing we're going after is direct air capture and then clean hydrogen. So the project that we have with CRIN, we made this unit that you see here. It's a mobile unit. So inside of that mobile, at the bottom picture, you see a mobile container that is on the wheels. And inside of that is this unit that we manufacture in-house here in Vancouver, in British Columbia. And that is exactly what I show you about human lung. So you can think about it in industrial lung. It operates under ambient condition. It has about half a cost, both operating and capital. It actually generates 5% better efficiency. That's a bonus. And also we have at least 80% less carbon footprint. So the analysis showed about 85% lower carbon footprint. The analysis were done all by third parties. So here's the test results. So the same unit that you saw in the previous slide was parked by this biogas upgrader, which is in Ontario. EPCOR helped us to secure this site. So it's a large anaerobic digester, and currently they are just burning that biogas to make electricity. So we want to upgrade them for renewable natural gas production. So taking the biogas, removing carbon dioxide, H2S, and other contaminants, generating pipeline quality, natural gas quality. So you can inject it pipeline, and that way we reduce the consumption of the fossil-based natural gas. The performance numbers up there. So it's performance were quite high, about 98 to 99.8% recovery of methane, and also purity exceeded the targets. What we did, we removed one of those beds or units that you saw there in the previous slide. These are what we call them beds, and we brought it back to our labs after thousands of testing, and we ran a breakthrough test to show if the bed still is healthy. And the lines, you can see they're completely overlapped. So there was no performance loss. There was no degradation, which is good news because we are promising our current customers in our contracts that our bed's going to last at least 8 years. So next step of the project is the scale up. We're still actively working on that. So the mobile unit you saw was the picture there on the top. The next one is the mini unit. We have designed that one, and also mid-size, which is the size that we are developing. And the mid-size, we are developing that under project that we have with CICE, and 40SPC is buying our first unit for BC site that we identified. And so this will be our first commercial project that will do full scale. And then the very largest scale there is a max scale, and that's still under development. We just started working on that. So the max size will be used for landfills, large wastewater treatment plants. So our scale of production is something that we are working actively on it, and we are raising capital in our Series A to take our current manufacturing facility we have and extend it to be able to sell about 50 of these units a year. Our goal is to reach about $120 million of sales per year. So the project is successful. I wanted to thank CRIN and others also that they helped us to do this project. Very important. I was the other day thinking about it would be almost impossible this is my second startup, to do it without the help from CRIN and also other funding bodies, because otherwise it's very difficult. What happens, like in my last company, which I got completely diluted by venture capitals, and basically we couldn't get what we wanted to finish. So this help from the support that comes from the government is very helpful in early stages, the company to start. And then we get to the point that we want to go and get the venture capital money to do the round Series A financing, which is now. Then this is the right timing after 4 years. So partners that we have are these companies that you see here. Modern Niagara will be very helpful building our first pilot plant that we tested. Standard Nutrition is one of our partners in US. EPCOR was very helpful securing the site. We are working with Boeing and Stonefisher and Fortis for the next project, which is the scalable technology, also direct air carbon capture and removal of rare gas production from air for the satellite industry. So those are other applications that we are now actively pursuing. Thank you very much for your time. If you have any questions, I appreciate it.
Thank you, Sohail. And so now we will move to the question and answer, and I would like to ask our three presenters, Katrina, Zach, and Ali, to join us, maybe those chairs here in the front, and invite questions from the audience here in Calgary and online. So yes, so thank you for turning the chairs. And so do we have questions here? Questions here? I see, we're still doing musical chairs.
Hi, good morning. This is Somay. I have a question for Sohail. I was wondering, you are producing RNG by biomass, right?
That's correct, yes.
And then these beds are used for purifying.
That's correct, yes. They're for
Is there any like project on the way to regenerate the beds?
The technology calls interrupter. The R in interrupter stands for regenerative. So the beds gets regenerated every about every 90 seconds.
So the
Automatic.
9 years, sorry, 8 years you mentioned, like the bed can work is without the regeneration or with regeneration?
It's a cyclic process, so it gets regenerated every 60 to 90 seconds. So you saw there was like 8 beds there or 16 beds in different configuration. Each bed goes through certain steps, and one step is, of course, capturing the carbon dioxide. During that 1 to 2 minutes, the same bed goes through a regeneration step that gets regenerated in the process, and again back to the process. So it's almost like going around. The beds are stationary, but the flow goes around.
Okay.
And the 8 years is the life expectancy from all the damages, let's say for operations that under harsh environment, maybe error with the operator's error, things like that can happen. Sometimes you can have conditions that the bed would be damaged. So we're looking at every 8 years to replace them as part of our sales agreement.
Okay, and then another question, like the regeneration would be at the ambient temperature too?
That's correct. Yeah, same way that in our lungs gets regenerated under ambient conditions.
Okay, thank you.
No problem.
Question for Zach. Can you tell us a little bit about H2 Nano's growth journey?
Sure. So H2 Nano has been working with the oil sands mine operators since our first product in 2018. So it's been some time getting from the beaker to field scale. Through this has been, principally through engagement with those COSIA members, through funded pilot programs, and then support like the CRIN network to be able to help us with successive scale up. So focus for us has really been progressive de-risking and testing at each successive stage, learning more about how the technology works and figuring out what we need to do to make it better before we get to that next scale of demonstration. So
Okay, thank you. Ali, can you address the same question? Commercialization.
Sure. Yeah, for us that we are dealing with underground technologies was very challenging. I mean, we started back in 2019, but it took us 4 years to deploy our first pilot. So we are a spin-off from University of Calgary. So we developed this technology at the University of Calgary. And then just last year, we started our first pilot, and now we are on the pilot number 3, thanks to CRIN supporting this project. And now we are on the scale-up process. Basically, we are trying to at least have 10 pilots, hopefully next year, to get more data, to validate the technology for CO2 storage and carbon intensity reduction. And hopefully after that, we'll be initiating the commercialization journey.
And how has CRIN grown through the number of pilots?
So the first pilot, the data from the first pilot, which was very positive and promising, that helped us a lot to get the second and third pilot almost immediately, basically. But getting that first pilot was very challenging. It took us 4 years. Before that, we were scaling up our technology, improving our manufacturing, but still that first pilot was crucial, and we could secure that with CRIN funding, basically. So that was very helpful for us to get the data we need to go to the second and third pilot.
Thank you. Katrina, a similar question for CVictus. Can you tell us about your partnerships and through your development, through the development of the technology, and where commercialization is at?
Sure. So our technology, as I mentioned in the presentation, is based on 2 commercial technologies kind of being pushed together in a novel format and application. So our founders, one of our founders, he's the inventor of EHR. He is pretty much the world depository of all of the information, all of the successful commercial applications of underground coal gasification. So he kind of came together and built CVictus as being the first commercial project developer of the EHR technology. And this is our first commercial facility. So he's done pilots using UCG, and then we've done our own CO2 injection pilots here in Alberta on the same site. So both of those technologies we think are at a TRL 9. By combining them, we're kind of at a TRL 7. But because this is such a large scale technology, we really need to go in and prove it at a large scale. We can't do any smaller scale pilots other than what we're calling our first commercial facility as a calibration plant. So it is commercially viable. We will make revenue off of this, but it is really to prove out the technology at this scale. Yeah.
Are you experiencing any challenges with getting industry to pay more attention or be more interested?
I think there's a lot of interest and excitement behind the technology. A lot of people think it's too good to be true. And so we really need to get this first facility up and running. The proof's in the pudding, right? We can show them as much modeling, as much calculations to demonstrate our low cost, low carbon intensity. But we really need to do it at scale to have the proof there. And that's one reason that CRIN's been so supportive, right? Or so beneficial, is that helping us get through that first real demonstration at commercial scale.
Great, thank you. Last question for Trent. Similar question. You mentioned you've done 8 customer-focused surveys. You're at TRL 9. It's commercial. You have proven the technology. What are the challenges to getting new partners in industry and getting more interest from industry?
Thank you for the question. And yes, we've done lots of pilot work in the field, successful, continue to learn. Most of the learnings have been around the broadband and the frequency content and the low cost mobilization. And the challenges or the barriers to continued growth and expansion is going to be mainly, I'll call it internal, and it's more on the self-promotion and trade shows and strategic partnerships, and basically just getting out there and selling it and all the benefits that the technology comes with. And we're at the stage now where we have the data and getting the last bits of data that can be released by the clients, because a lot of the survey work is proprietary, so they won't release the data. That has been a bit of a challenge, to the point where next spring we're actually going to be doing our own project on our own, in partnership with a firm that will allow us to release all of our own data. So that's been one of the challenges, to make sure that we own our own data that we can then use to promote.
Okay, thank you.
Okay, any more questions? So seeing none, I will bring the event to a close. Thank our 5 speakers for their contributions today. Thank the audience for your insightful questions, and look forward to additional events by CRIN. I'm sure Sally and Amber and Lindy will keep you appraised of those opportunities. Thank you. Have a good rest of the day.
Thank you very much.
Thank you. Thank you.